All right, our next lesson is on proportional versus non-proportional relationships. This is going to sound complicated, but in reality, it's just a little bit of calculating and it will make sense. So I filled in the blanks so I could write it neatly before I started recording. If the ratios or rates, basically the fractions, are equal, then the quantities are proportional. If they're not equal, they're non-proportional. So imagine you're baking and you have a recipe for cookies and you want to double that recipe. If you don't double every ingredient, your cookies will be horrible. So suppose you don't double your flour. You will have very wet cookies. If you don't double the chocolate, that will be very sad and you won't have enough chocolate chips in your cookies. So we want proportional relationships. Recipes, whether it's for slime or cookies or whatever it is that you're making, if you are not increasing it at the same rate, then they're not going to be the same product. So let's look at an example with cookies down below. So Jasmine is baking cookies and mini cupcakes for a competition. The table below shows the number of cups of sugar she has used for each dessert after every 3 dozen made. So complete the table and determine the type of relationship. So basically, did she get it right? Did she use the right amount of sugar? What we're going to do here is do sugar divided by dozen. Sugar is the bigger number here, so that kind of makes sense to be able to do amount of sugar per item, kind of like our unit rate. So let's take 12 and divide. I'm not going to write this out for all of them because it'll get long. 12 divided by 3 gives us 4. 22 divided by 6 gives us 3.6 repeating. If I take 36 and divide by 9, I get 4. And 45 divided by 12 is 3.75. So I'm taking the number here and dividing it by that for each one. How much sugar per dozen? Does this look even? No, I mean, these two look even. She used 4 cups of sugar per dozen, but then she got it wrong here. So these batches are going to be less sweet than the other ones. So the sugar is non-proportional. They don't match. And the reason is the numbers are not all equal. I'm not going to fill in a whole sentence there. But basically, because the rate of the sugar is not equal, we can see it down below, or up above, I should say. Those are not equal. Well, let's write down a kind of a cheat answer there versus writing the whole sentence. What about our cupcakes? Let's figure out what happens there. Let's do sugar divided by dozen. 9 divided by 3, 3. 18 divided by 6, 3. 27 divided by 9, 3. 36 divided by 12, 3. This is getting boring, right? This is how it should work. You should have a consistent amount of sugar per dozen. So the sugar used in mini cupcakes is proportional because all of them are equal. So something went wrong with her cookies, but she was very consistent with her mini cupcakes. So all you gotta do for these is divide. And when you're not sure what to divide by what, typically the bigger number should go first. So $30 divided by 5, let me move that over here actually. We won't do all these out, but 30 divided by 5 gives us 6. 60 divided by 10 gives us 6. 90 divided by 15 gives us 6. And then 120 divided by 20 gives us 6. So this is, yes, a proportional relationship. And here it's asking, give me the constant rate. So this was number of items sold and amount raised. So it was $6. That's our answer down here. We kept getting that number 6, right? Per item. So that constant rate is the thing that we're looking for that repeats. And if the answer is no, which this one, if you divide, you'll find out the answer is no, there is no constant rate. So there's no other thing to write there. Okay? So let's look a little bit down below so we don't spend too long on this video. Let's learn how to fill in tables. This is actually much easier. There's no dividing, it's more multiplying. So suppose Lucy spends $1.75 on a cup of coffee each day. So if it's one day, how much does she spend? She spends $1.75. If it's 3 days, how much does she spend? Well, you have to just grab a calculator or do it in your head. but 3 times 175, which is 525. What's 5 times 175? Let's write this down first. That would be 875. Oops, I don't know how you erase that. And if I did 7 times 175, 1225. So it's just the amount that she's spending times the number of days. Let's do one more example. We'll do the next one. A car travels 52 miles each hour. So the first hour, that's 52 miles. The second hour, let's do that times 2, 104. For 5 hours, we'll do 5 times 52, which will give us 260. I'm using my answers here to do this quickly. 8 times 52 will give us 416. So that's the same for all of these. We're going to fill in the table with the value that we have. This involves fractions in the next one. We'll skip that for the sake of time, but you could turn that fraction into a decimal, or you can just work with multiplying numbers against fractions and do that pretty easily. But it just takes a little bit more time and effort, right? So, actually no, let's do that out really quick. I take that back. Jose uses, and the accent there is a little bit weird, so I apologize for that formatting, 1 2/3 bags of grass seed for every 400 square feet of his yard. So if he has 400 square feet, that's 1 2/3. If I do 1 2/3 as an improper fraction, because well, no, we'll just leave it as 1 2/3. What if I need to double that? So I have 1 2/3, and I want to do times 2 there, right? So what I can do is add 1 2/3 plus 1 2/3. That's going to give me 2 4/3, but that 4/3 is really 1 1/3. So this becomes 3 1/3. Let's try a slightly different technique for the 1200. If I know that 400 is 1 2/3, how do I get from 400 to 1200? I would have to do times 3. So what is that 1 2/3? Let me actually make this an improper fraction. 3 times 1 is 3, plus 2 is 5, and I keep the same denominator. So I do 3 times 1 plus 2 to get 5, and I keep the 3. Now let me take that 5/3 and multiply it times 3, which is really 3 over 1. If I do that, I get 15 over 3, but 15 divided by 3 is just 5. So 1 2/3 times 3 is actually 5. So no decimal or fraction there, which is kind of nice. Let's look at times 4, because to get from 400 to 1600, I've got to do times 4. So I'm going to take that 1 2/3 or 5/3, and I'm going to multiply that times 4. And it makes it easier to multiply if you do it times 4 over 1. 5 times 4 is 20. 3 times 1 is 3. To put that as a mixed number, I ask how many times does 3 go into 20? 6 times, because 6 times 3 is 18. That leaves 2 left over, and out of 3. If fractions are still tricky for you and you want to review that with me separately, I am happy to do that. That's the only time this gets complicated. If you're just dealing with integers or decimals like number 7 and 8, all you're doing is multiplying. You get to an answer pretty quickly and it's not too bad.